Hello, and welcome back. Day two, 2023. Let's get into it. So there's, again, a bunch of flavor text. Um, some of this is actually relevant to the problem. So basically, you're playing some sort of game where there's a bag with some unspecified number of uh, red, green, and blue stones. And so your input looks like a bunch of lines, and each line has a sequential ID. This is important. The IDs um, aren't arbitrary. They just count up from one. And then between all the semicolons, you get a list of the um, between each semicolon, the person you're playing the game with pulls out a handful of stones and shows them to you, and this is how many of each color were in that handful. And so for each game, there's a couple of handfuls of stones that are shown to you. And for part one, it asks which of the games or lines would be possible if the game only had 12 red cubes, 13 green cubes, and 14 blue cubes. So one way to think about this is because the stones are replaced in the bag each time you're shown a handful, each one of these are independent events. So really the only way that this bag configuration with 12, 13, and 14 stones would be impossible is um, if you're ever shown a handful of stones that has more than these. So like if you get shown a handful of stones and it has 13 red cubes, whatever the rest of the contents of the line are, you know that particular line or game is impossible, right? So basically, what you want is you want to look at how many stones are shown, and you want the maximum number of any particular stone that's shown within a particular line. The fact that these are separated by semicolons and they represent like different handfuls that are shown to you is a little bit of a red herring, or it's kind of unnecessary work to uh, group around these semicolons. I actually I did that when I originally solved it, but if you think about it, you're just interested in um, the maximum number of stones that you see throughout the playing of a game, right? For part two, we ask what is the fewest number of cubes of each color that could have been in the bag to make the game possible. And again, uh, like if you know the maximum number of cubes for each color that get shown for a particular game, then you know that the bag has to have at least that many cubes in it, right? But you don't need any more than that. Um, so again, you're really just interested in the maximum number of stones for each color that are shown to you. And that is also the fewest possible number of cubes that would make the game possible, right? And then in part one, we basically do this thing where if you take only the possible games and you add up all of their IDs, which again count up from one. And then in part two, we multiply together the fewest number of cubes for each color for a particular line, and then we add all of them. So it's a lot of text to parse through and sort of some thinking about what it actually means to see these different handfuls of stones and whether or not you have to group by each particular handful that's shown to you. But really what we want to do is we just kind of want to parse this out and look at, so we see like 3 blue kind of pair here. And then later we see like a 6 blue pair. And so we want, for each line for red, green, and blue, we want to build the maximum the maximum number of stones that were shown for each particular color. So like we might start out with 3 blue, but later we want to update that to 6 blue because well, that's more. Okay, so we are going to be doing today in ng-k. It is back, and really we're doing it in K for one big reason. K has a killer feature, and that is dictionaries. So it makes it super easy to, when you're doing your parsing and you're scanning the line, it makes it very easy to keep track of the different counts for the red, green, and blue stones because those can occur in any order. You don't know what the order is ahead of time, so it makes it a little more difficult to put them into like a defined 3-element vector, let's say. So we're going to be using dictionaries very heavily to solve this problem. And by the way, if you want to get started with ng-k or you want some more explanations about K in general, I did a video recently called Taking a Look at ng-k. You can go check it out if you want. But we are going to start by reading the test input, and we'll start with the smaller example first so that it's easier to see with the large font on the screen, and then we'll transition and do it on the actual problem input. So we start by loading our file, and then for each row, that's that apostrophe each, we are going to split on spaces. So space, split. This is the train here that we're running on each row, and we're just splitting on spaces. And then we can drop the first 2 elements because those are the game and ID, the game identifiers. And we don't really need to keep track of those because we know that they are sequential and we can construct those later. So we'll just drop them for now. And then we want a way to consider each pair kind of individually here. So, we want to consider like 3 blue as one pair, 4 red as one pair, 1 red as one pair, et cetera, et cetera. And so we can reshape each row into a matrix with an unknown number of rows, but we know that we want it to be 2 elements wide. So this 0n is the numeric null value, and if you put it into a shape like this, it will infer the correct shape that you want. So everything is, each row is now a matrix where the left column is these numeric strings, and then the right column is our color identifiers. And so for each one of those rows, we are going to execute a function. And this period here is for apply. And this basically means when we use this curly bracket syntax, we'll be using named arguments. And so the numeric values will be assigned to X, and then our colors will be assigned to Y. And so what we're going to do is, first of all, we're going to parse X, or just eval it. This is basically going to turn it from a string into an actual number. And then we will construct a single element dictionary with the first character of Y. So you can see here, we haven't taken out any of the punctuation. So these colors aren't actually the same because some of them end in commas, some of them end in semicolons, and then presumably the last element doesn't end with any punctuation at all. So we can get around that by just looking at the first characters for red, green, and blue. These are all distinct. So we'll look at the first character, and then we will turn it into a symbol. And so we get a list of dictionaries for each row, and then we just need to do a max reduce. And so for each row, we're doing a max reduce across a list of dictionaries. And so when a key is present in the dictionary, as it's reducing from left to right, that key will be updated if there's a new maximum value that exceeds what was previously in there, or the key will be inserted if it hasn't been seen already. So if we do this max reduce, we get this very nice list of 3-element dictionaries for each color. And we will call this P. This is our parsed input. So for part 1, we have a particular number of stones that we want to check. So it's 12 red, 13 green, and 14 blue. And we want to check to make sure that each row, the values for those particular colors are less than or equal to these values here. So we can start by doing a range of 3 elements, and if we add 12 to that, we get 12, 13, 14, and then R, G, B, make a dictionary, and this is the dictionary that we're going to be checking against. Now remember that there's no less than or equal to or greater than or equal to in G and K. So you have to kind of take the opposite sign and then apply a not. So we're going to say P greater than, and then we're going to compare this dictionary that we've constructed against each of those rows. This is the each left adverb. And that gives us a bunch of Boolean values, and we'll apply not because we're actually trying to simulate less than or equal to here. And then we can check to make sure that all of the colors are possible by doing an and reduce on each row. And that gives us a Boolean vector. Now we can do where to figure out the indices of all the ones here. This Boolean vector basically corresponds to, so we had 5 lines in our test input, and we have a 5-element Boolean vector. The ones mean that the line is possible, the zeros mean that it is not. And so if we do where to get all of the indices, and then increment all of them by 1, because the IDs are 1 index, but we're 0 indexed here, and then we add all of them together, we get 8, which for the test input is correct. And then for part 2, we parsed out all the maximum values for each of the 3 colors of stones. And so all we really have to do, the power of a set of cubes equal to the number multiplied together, and then we add all of them up. So we can take a look at our dictionary here, and then for each one of these, we just multiply everything together, and then we add them to get 2286, which is the answer for part 2. If you put all of this together, you get, I did it anyway. This is not the right one. Hang on, sorry, give me 1 second. Okay, here we go. But this is, you can do this with strings too, but just to keep everything the same, we'll do symbols here. Okay. So this is the 2023-02. This is our actual input. And so we can just copy this into our REPL here. And we get 2176 for part 1, which is correct, and 63,700 for part 2, which is correct. So this is the entirety, to make this even bigger maybe, This is the entirety of our solution for 2023 day 2 in Ng and K. Yeah, I originally solved this in APL, and it was I think it's probably a lot easier in APL if you use regular expressions, but I like to use just regular primitives. And when you're doing that, it's quite difficult without proper string split functions or, in fact, dictionaries. You have to figure out an order for everything to go in and construct vectors, and it just ended up kind of being a mess. But I think that this solution is pretty neat, and it sort of showcases the utility of dictionaries, and also having a primitive string split function is also very nice. So yeah, that is day 2. Stay tuned for more. 2023 keeps on rolling. Thanks for watching.